This is Dove Isaacs at Adobe in California. Uh, Thank you for signing up and attending this webinar. What we're going to talk about today is print workflow, PDF 2.0 and PDF X-6. These are standards that are in the process of being completed. In one case, it is completed with a particular dated revision coming out, and PDF X-6 is about to go to ballot for a draft international standard in the next few months. And what we're going to talk today is pretty much what this portends for the print marketplace, and for those of you who are in design, print, etc. Okay, let's give a little bit of background. First of all, print is not dead, but is changing dramatically. You have the old print. These are things that we used to love and think about when we talked about print, typically books, magazines, newspapers, manuals, marketing collaterals, all these types of things. There's overwhelmingly paper substrates. In other words, we printed on something that was formerly a tree. There's overwhelmingly plate-based offset, gravure, and flexo printing. Typically, we would print long run centrally. We'd warehouse those and distribute the results. In terms of digital printing, it was primarily for short runs, proofs, and enterprise printing, and at least at the beginning, primarily monochrome. The old print typically was content designed for particular, very specific print conditions, CMYK and spot colors only. The content was only primarily from graphic art-centric applications. Your digital imagery was typically converted to device CMYK early in the workflow. These workflows typically had long lead times and correspondingly high expenses in adjusting the colors and getting the content to be just right. It was device-dependent PostScript and early PDF workflows. It was boring and increasingly limited profitability as the marketplace has changed. What about the new print? Well, the things that we used to print very often are going on screen or is downloadable as PDF files from the internet. A lot of that marketplace has gone away and it's not coming back. It increasingly consists, the print marketplace that we are looking towards increasingly consists of packaging, signage, textiles, as well as personalized, specialized items of all types, car wraps, bus wraps, wide format printing, packaging especially. We can print on anything and everything, including paper. Okay, in other words, very often we're printing on plastics, textiles, etc. Increasingly, it's digital and wide format printing, facilitating the possibility that every single copy can have personalized content, something we call variable data printing. It's increasingly print on demand or short runs, multiple locations, multiple press types and print conditions. And it's increasingly using very rich color. It's not just processed CMYK and boring old spot colors, but increased gamut using high fidelity colors, brand colors, metallics, fluorescents, pastels, textured varnishes, etc. Design content is primarily being done both for web and print these days. Increasingly, it's designed for a web first using color managed RGB. So the assumption that you're going to get content that was originally done in CMYK for a particular print situation is just wrong anymore. That doesn't happen that way. Even if you get CMYK, there's a very good chance that it was originally done in some type of device independent RGB. High level of graphic complexity, including transparency, both explicit and implicit, and PDF workflows are based on more recent PDF versions. A little bit of background. What is PDFX? I assume that if you're attending this webinar, you probably have heard of it. You might be using of it. It's a subset of the full PDF specification for use in printing. It was based on a need of the printing industry for a reliable exchange of graphical content. Excuse me. It limits which PDF features can be used, requires use of specific PDF features, and specifies how they must be used, and fonts must be embedded. including those base 14 fonts. There are no fonts by reference. In other words, if you use a font in your source document, that font has to be embedded in the PDF file. Certainly as a subset, but you have to have that there. You can't count on it being on the RIP on someplace else. It specifies the method of PDFX version identification and addresses concerns about the use of unconstrained PDF for printing. For example, JavaScript, movies, sounds, etc. PDFX has been evolving over the years. It has evolved to meet the changing imaging models, technology, and industry needs since 1999 when the first PDFX version came out. In those days, everything was opaque. Transparency effects were simulated by overprinting and other hackery. Color management was in infancy. That's why everything was CMYK and spots. Most commercial printing was offset press, typically film to plate and then emerging computer to plate directly and then most of the PDF was created via distillation of PostScript, and most PDF printing was via conversion of PostScript and then printing the PostScript. Presently, transparency effects are ubiquitous. Even if you don't think you're using it, you probably are. You need the ability to repurpose content in general and PDF and in PDF as a requirement. Digital printing processes are challenging offset printing up and down the line, especially in new marketplaces. Color management is a requirement, especially due to color managed digital imagery and digital presses. I will tell you that I know of no digital camera that produces CMYK. You also have support for direct PDF creation and printing. It ain't no stinking PostScript anymore on these things. All reasonably recent vintages of RIPs and digital front ends directly support ICC color management and transparency in PDF. So if you were to take a look at the different versions of PDFX and also compare them back to PostScript from years gone by, this is the scenario of what we had. We started with PostScript that was pretty much a device, CMYK and RGB. It had some color management, but it wasn't ICC color management. No transparency, no layer support, no page independence, no blind exchange. You basically had device-dependent job control via something called set page device, etc. It was highly device-dependent. PDF X1A, as of the 2001 version, was basically based on Acrobat 4, PDF 1.3. Again, it was device CMYK in gray as well as spot color. Color management was primarily left to an output intent, which was pretty much optional. You could specify a condition, which didn't necessarily mean anything. No transparency. If you had any in your source document, it had to be flattened, which had some real issues. No layer support, but it did have page independence, random access, blind exchange. The job control was external, etc. As we moved along, we got to what we currently have as the standard that is the one most recommended in terms of printing, and that is PDF X4. PDF X4 is based upon PDF 1.6. It not only supports device CMYK in gray and spot colors, but color managed colors as well, ICC color managed. Okay. Supports live transparency. No reason to flatten transparency. If you flatten transparency, you basically created a device-dependent PDF. RIPs can handle this. It can handle layers. It can handle page independence. We have job control that's external. Okay, and if you were to characterize it, you would say that it was much more device independent than any of the previous versions of PDFX or PostScript ever were. And this is, with some exceptions, this is what we recommend today for modern workflows. Okay, well, what is PDF 2.0? Well, PDF 2.0 is an ISO standard, 32000-2. It's a standard developed by ISO TC 171. It was published in July 2017 after 9 years in development and was 984 pages in length. First new specification since PDF 1.7 was published in 2008, and it's the first non-Adobe version of the PDF specification. Anyone who tells you that PDF is something Adobe, well, we may have created it, but it's now an international standard, and we're now on the second version of it. There's actually, excuse me, there's actually going to be a dated revision, mostly editorial corrections, some limited technical changes, going for a vote, and we expect that to be published in early 2020. Well, what is new in PDF 2.0? Well, first of all, I wouldn't recommend you try reading the specification, but the specification now conforms to the way that most ISO specifications read. There are lots of corrections and clarifications to the text in the PDF 1.7 specification. It adopted some new augmented features to ISO PDF. Some of these were already in Adobe's PDF 1.7 extensions. It supports some things that came from PDF VT, such as something called Depart, and other features for a wide range of PDF use cases and content. It has a number of corrections, clarifications, and augmentations of existing features, and deprecated some obsolete features, such as XFA forms. If you don't know what an XFA form is, don't worry, it has nothing to do with print. Okay, well, what are some of these features, especially those for print? Well, there's something called black point compensation, which was originally an Adobe extension to ICC color management, not officially part of PDF, and typically globally enabled in any Adobe application or in any Adobe renderer. This is now an ISO standard 18619. I don't expect you to memorize the number, but it basically is a methodology for creating adjustments between the maximum black levels of color managed digital content and the black capabilities of the rendering device. I'll give you an example. I don't know whether you'll be able to see this particularly well going all the way through the meeting software, but on the top sample, black point compensation is disabled. If you take a look at the colors on the left, the gradations of gray, it's all muddied out. You can't tell the differences for at least the first four of these. When black point compensation is enabled, there's a clear differentiation between the colors on the left. Well, most of us do not actually print charts like this in day-to-day work, but we do things such as this. And again, this is very subtle, and when you get a copy of the presentation, you can look at the differences between these particular samples. In the right case, black point compensation is disabled. And if you look at the treads of this tire, it's very hard to see. When it's enabled, you see the treads much more distinctly. Also, some of the gradations over on the left here of gray are much more capable of being seen when print. Now, black point compensation actually is something associated only with color management. In other words, you have an existing CMYK image, black point compensation does nothing for it. It's for when you have content that's in a device-independent color space, such as Adobe RGB, sRGB, etc., and you tag it with a profile. If black point compensation is on, when that's converted to CMYK, preferably at the RIP, black point compensation would handle that differentiation of the dark tones. What we've added in PDF 2.0 is that this is now part of PDF itself, and you can specify either it being a default value, typically something the application would set, or specifically offer on. And this is something available with all PDF 2.0. It's not PDFX dependent, and the PDF X-6 standard will support this directly, as well as applications that will support PDF X-6. What about transparency? Well, it was originally introduced to the PDF imaging model in Adobe PDF 1.4. It is unchanged in PDF 1.7 and in ISO PDF 1.7, but in PDF 2.0, there have been the whole description of this has been rewritten. There are no new features. It includes implications for black point compensation and their corrections to the specification to match how we actually implemented it. There are also some clarifications to eliminate ambiguity of the specification. Example is something called the color space inheritance model. It's applicable to all PDF 2.0. It's not PDF X dependent and will be inherited by PDF X-6. The important thing to remember is that if you have PDF X content that was created for PDF X4, it should have, these changes should have minimal, if any, impact on your content. But this is, the changes in the specification were primarily to make it easier for implementers to do it right. What are the implications in terms of applications? This is something that probably most of you aren't really concerned about, but it's how transparency groups are used to avoid unintended results and overhead. You want to avoid specification of these transparency color blending spaces. Again, this is something internal to people who understand PDF itself, the internals of it. It's not something which you typically would see in a design application. Okay, something else new added in PDF 2.0, page level output intents. Okay, well, what's an output intent? Well, introduced into the Adobe PDF specification to meet the needs of PDFX, earlier version of PDFX, and also adopted by PDFA and PDFE, this defines the default transparency blending color space, as well as what the CMYK or otherwise color space is you're converting non-device CMYK colors to. Okay, it has no meaning for anything other than these subset standards such as PDFX, PDFA, etc. But it is basically one document output intent in everything before PDF 2.0. With PDF 2.0, we have the option to specify page level output intents. Okay, and this is only, again, only appropriate for PDF subset standards such as PDF X6 that explicitly define their usage. What does this really mean that I could have a page level output intent? Okay, if you have only a document level output intent, if you have a document level output intent, any page level overrides the document intent for that particular page and serves as the page's transparency blending space. If no document level output intent is provided, each page must have an output intent defined, serving as the page's transparency blending color space. Well, why would you want this? Why is this important? Well, in conjunction with something called depart metadata, it enables a single PDF file with multiple page types to have different printing conditions based on the type of press or substrate used for each particular page. We'll give an example of this a little farther down, but basically it would take, imagine something where you have a single PDF file, which the first page is a cover and the next page is a text pages. The cover may be on a colored paper, different type of substrate that has different color characteristics. So you want that to have a different device CMYK than the text pages of that document. We'll give examples of this. Okay, the thing is that in terms of what you have to do in applications such as in design, etc., will need to be significantly re-engineered to support this, to be able to define different color spaces on a per page basis, and that this would be passed through the resulting PDF X6 that's generated. Okay, there are other things that are also been added to something called the Output Intents Dictionary enhancements. We've supported better support for device end and spot colors, support for something called the Mixing Hints Dictionary. This is something beyond what we're going to talk about today. Spectral data dictionary, such that you can add spectral color definitions for spot colors using the CXF X4 spot color characterization data. This is also an ISO standard 17972-4. Since again, this is an output intent, it will require PDF X6 as opposed to just PDF 2.0 in general. Document parts, what's that? Well, this is a capability of PDF that was introduced by the PDF VT standards a number of years back for purposes of identifying different page types, as well as being able to identify contents on the page as metadata. Okay, now we've officially put this into PDF 2.0. It gives us the PDF file infrastructure for supporting documents with multiple parts and page types. This goes hand in hand with the ability to have different output intents on a per page basis. This is very important for getting rid of the need to have separate source and PDF files for different parts of a large product. The product may be a book, it may be a marketing campaign, etc. We'll give an example. It will require PDF X6 because, again, this is being used in conjunction with page level output intents. Okay, and there's actually a formalization of the deep part data, and that's another ISO standard 21812. We'll review this in a few minutes. Halftone origin. This replaces a feature that was in PDF before PDF 1.3, something called HTTP, that allows you to specify the location of the origin or phase of a halftone to be specified. This will primarily be most useful in manually imposed applications such as step and repeat. It will be available for all PDF 2.0. It's not PDF X6 dependent, but it will be inherited by PDF X6. Okay, well, what is PDF X6? I've mentioned this a few times. Its formal name is Prepress Digital Data Exchange of Printing and Data and Partial Data Exchange for Printing Data with External Profile Reference using PDF 2.0. Most important thing is it's PDF X using PDF 2.0. It's a group that its development is a responsibility of ISO Group TC130, Working Group 2, Task Force 2. I am the chair of that group. We expect this to become a draft international standard very soon. Publication likely 2020 with applications to follow. It's the first new part of the PDFX specification since the 2010 updates for PDF X4 and PDF X5. There are three conformance levels for this PDF X6. One is PDF X6, which is complete exchange. PDF X6P allows external output intents. In other words, you can reference those as something outside the file. And PDF X6N allows external output intents with N-colorants. It will also serve as the basis for PDF VT3, an updated version of PDF VT1. PDF VT1 is currently based upon PDF X4. PDF VT3 will be based upon PDF X6. Okay, well, what's new and different? It's based on PDF 2.0 instead of Adobe PDF 1.6. It inherits the PDF 2.0 features unless explicitly prohibited. To support modern digital print workflows, it's supporting page level output intents, deep part data, as well as the mixing hints and spectral data definitions. It is very much in alignment with PDF-A for archiving. Matter of fact, we expect that applications will allow PDF X6 files to also be tagged as PDF A4 files. As such, you will be able to have a file which will meet the needs for print production as well as archiving instead of having to have two separate files. It also allows annotations, including digital signatures, form fields, videos, etc., in the printable areas of pages. A video inside of a PDFX file? You wonder, why are we allowing that? Well, we don't know of any RIP that actually plays movies. That's not the issue. The question is that if you have a movie specified or another interactive type of feature inside of a PDF X file, what you really want to be able to show is the proxy. So typically, if you have a movie embedded, you'll have a representation of the frame of a particular movie, the title of the movie, a scene from the movie as a printable representation. That will be what's printed, and as such, you can have the movie embedded for somebody who wants to have an interactive access to this. Okay, this was not permitted in PDF X4 and previous versions of PDFX. So what does the new PDFX lineup look like? We add under the new column over on the right, shows the differences. We support annotations and forms. By the way, forms is another thing that you can have, since a form in PDF is an annotation. If you have a filled out form, why shouldn't you be able to print it? This was a complaint that we've heard over the years. It supports multiple page types. Okay, it supports everything else you've come to know and like in PDFX, but it's more oriented towards workflows of the future. Okay, well, I mentioned the possibility of a multiple part document or some sort of product. Okay, and let me give you an example of something like this. Suppose we have a book and a poster. The book is called Romantic Kuzbania, a fictional country, and this book has been written by Gustav Hunkledinkel, University of Northern South Dakota at Hoople. It has a book cover. Okay, it has text pages, it has full color illustration pages on nicer paper, of course, and full color map pages which get folded in, glossy paper, etc. And coming with the book is this beautiful single page poster showing a feature of Romantic Kuzbania and its map. Right now, if you were to do this with today's workflows, you would be using possibly up to 1, 2, 3, 4, 5 different source documents, whether it's InDesign, Quark Express, etc. It would be nice if you were able to submit this as one single, have one single source file in those applications and one PDF file that when it goes into your RIP or your DFE, it was able to take it apart and send the appropriate pages to print, be rendered on the appropriate devices with the appropriate substrates, etc., with appropriate color management for that particular page type. And that's what is supported by PDF 2.0 and more specifically PDF X-6. You'll probably have trouble looking at the details here. We will we'll have the presentation downloadable. But this is typically what you would have. In the source document over on the left, you would have all these pages. You'd identify them: book cover, text pages, illustration pages, map pages, and poster. The output intent would be different for each of these page types. This first one, you'd have one particular representation. The text pages, which would be printed monochrome, dot gain 15%, let's say. For the color illustration pages, let's say Great Call 2013. Same is true with the map pages. The poster might be Fogra 51. I'm not trying to give a recommendation, but rather an example of differences. The depart production metadata would give information as to what you would do with these. For example, the book cover might be specified in something like InDesign as a book cover, and the workflow would add in other information, such as the fact that it's going to be on ragged cloth, it's going to have a particular, it's going to be one-sided, it's a spread as opposed to a single page, etc. Text pages, we might call book body, though it's going to be on matte paper, it's a certain type of substrate, etc., a certain page type. The color pages, again, this is going to be two-sided printing like the text pages, but it's a different type of paper, has a different type of coating. It's a glossy coating. And the same thing is true for the other examples here. So essentially, we go from a workflow of 5 different source documents, 5 different PDF files, to a single source document, a single PDF file, and the RIPs and the DFEs in the future, and this stuff is actually being worked on now, will be able to take apart the PDF file and do what's appropriate, whether send parts of the certain pages to different printers, use different substrates on the same printer, etc. This is something that is the workflow of the future. Okay, well, how do we prepare for this going forward? Well, I think the first thing that's important to do is finally embrace and adopt 21st century best practice end-to-end publishing workflows based on PDFX4. Okay, it's time to finally get rid of PDFX1A or earlier workflows. You want to maintain your digital assets, raster imagery, as well as vector artwork, destined for both print and web in their original color spaces with any live transparency until it's actually rendered, whether the proofer or a RIP DFE. In other words, don't convert to a final CMYK, don't flatten transparency, etc. Don't misuse spot color swatches. There's too many designers will pull out a Pantone color, which is out of gamut, and expect that somehow that's going to be taken care of. Don't do that. Don't misuse those. There are color books that provide colors in a device-independent manner that are within the gamut of typical CMYK printing. That's what you want. Use those swatches, but not spot color swatches. Specifying PDFX4, but requiring device CMYK and pre-flattened transparency is effectively a PDFX1A workflow, perfect for the late 1990s. Don't do that. If you're going to use PDFX4, you want to let the original colors through all the way to the RIP. I'll be very clear about it. The RIPs that are using Adobe technology and RIPs using, to mention a competitor, Harlequin technology, all support proper conversion of device-independent colors with ICC profiles to device CMYK at rendering time. Same is true with dealing with live transparency. This is handled properly at the RIP. Don't ruin your PDF by creating PDF that has device CMYK and flattened transparency. The idea that if it ain't broke, don't fix it is generally the mantra of Luddites. Those of you who don't know what a Luddite was, those were the people who revolted against the Industrial Revolution in England. Okay, if you can't recognize the symptoms that are processes that are very broken, you have a problem. So the idea is that you have to look forward. Yes, you do have to have standard operating procedures that work, but that should not blind you to what you need going forward. Again, the old print is not the new print. The new print has needs that well go beyond those of the print that we had in the late 1990s. And one thing which I picked up surprisingly enough from a presentation last week at the Hong Kong Printers Association, the thing that we have to do in this industry is learn, unlearn, and relearn. The things that we learn early in our careers are how to do things, best working or best practices, but in many cases we have to unlearn those and relearn practices that are appropriate going forward. If you basically have set yourself up for best end-to-end PDFX4 workflows, then you will be in pretty good shape to adopt PDFX6, both in terms of certain capabilities of your source files and what you're doing to meet current needs, as well as having the attitude of being willing and able to move forward. Okay, at this particular point, I'm done. Is there anybody who has any questions that I might be able to provide some answers to? Blind exchange means that it has nothing to do with printers who don't have their full eyesight. That's not what we're talking about here. What it means is that I can send something to different devices between different people create to someone who renders it for print without having to worry about the conditions of the person who creates the content. In other words, everything's there. The fonts are there, the color characterizations are there, etc. Nothing's left to chance. I'll give you the example. In PDF X4P, the profile is referenced externally. And that's something which, if you can't find that profile when you print, that's not really blind exchange. That's why in my charts, I show that with a yellow light as opposed to a green light. It's really not blind exchange. Same is true, there's a version of PDF X4 called PDF X4G that allows you to define graphics externally as PDF files, something called a referenced X object, where essentially if you wanted a graphic stored on a server someplace, that could be brought in at rendering time. That is not blind exchange because you're dependent upon something being there at the time you need it, and it's external to the PDF file. So blind exchange means that you have everything you need for rendering that PDF file at the time that at all times. Hopefully that answers the question. There's a question, how will this be handled per page with rendering intents in design? Additional settings the designer needs to set up for different kinds of pages based on what paper content will be used. Very good question. Part of my day job here at Adobe is to help define that right now. I'll give you a preconceived notion of what we will do. If you've used InDesign with XMPy, for example, for producing variable output, PDF VT output, they use the master page as a way of keying on types of pages. The preconceived notion is that when we start supporting PDF 2.0 and more specifically PDF X6 in InDesign, and also let's say in Illustrator where you can have multiple artboards. In the case of InDesign is the easier one though. What you would do would be, let's say for a master page can override the color space, the output intent color space for the document. And that any pages you create from that master page will inherit that different color space setting. Okay, and conceivably we might even allow you to specify different default RGB, but that's probably not what we'll do. But in terms of the output intent, let's say you have swap for one type of pages and FOGRA for something else, that would be defined at the master page, and it would be inherited by the pages created from the master pages. That seems like the easiest way to do that. And by the way, the other settings, such as whether it's a cover or a text page or a poster or what have you, would also be handled in a similar manner. In other words, define it at the master page. The pages that come off the master page, the created from that master page, would inherit not only the color space, but the type of page for this depart data that would go into the PDF X6 file. Is it possible to set the page level output intent in Acrobat? That's to be determined at this particular point. At this particular point, even for PDF X4 files, PDF X1A files, the setting of an output intent is typically done before you create the PDF file, and there are some capabilities in pre-flight that enable you to change it globally for a file. We're hoping not to have to provide this as an explicit function in Acrobat. Probably something will be done in pre-flight to allow you to fix something afterwards. But the best way of handling this is obviously to create the PDF X6 file with this in it initially. Yeah, pre-flight will probably have that support. I'm talking with them now about that. Okay, well, if there aren't any other questions, I thank you very much for your attention, and I'm looking forward to the next part of this particular adventure in terms of a PDF standard. And certainly you have my email address on this presentation, for better or for worse. So if you have any questions I might be able to answer going forward, please feel free to contact me. Thank you all, and have a good day.